Good morning, everybody. And I know you've been anxiously waiting for this Mr. Newbert's third installment of Mr. Newbert's amazing video lesson to come out. We have a visitor this morning. One of our cats is wandering around the basement with me, checking things out. We're going to be talking about speed today. I have my bike in the background there. My trusty steed. I was out riding this morning, did about 20 miles. It was a little cold, but I was out there biking this morning. Because we're talking, I have it here because we're talking about speed. Wearing my Team ER shirt, which is a team, I'm not sure what the cat did over there. My Team ER shirt, which is the team I ride for. Our sponsors are Eddie's Bike Shop and Richie's Sporting Goods. I race triathlons in the summer, including on that very bike. So, calculating speed. You're going to need your textbook. You're going to turn to page 10, so hit the pause button right there while you get your book. And we're back. All right, so you have your book, turn to page 10 and 11. Oh, and there's Nemo. There he is. Wandering around, snooping around, as he usually does. How'd you like to see him? All right, here we go. So, on that page is, bottom of page 10, 11, is the riders in the Tour de France. Tour de France is one of the most grueling sporting events in the world. The riders race for 20 days, 20 stages, over 2,000 miles. So it's an average of about 20 or 100 miles per day. And not on flat ground either. You're talking about mountains, the Alps, Pyrenees in France, and they travel all over the country, and for 20 days end up in, the last day is always in Paris, on the Champs-Élysées, and where they finish. This year, because of our situation with the virus, it's been postponed. It's still being planned for late August and into the entire month of September. So Tour de France will go on. That picture happens to be the ride is going through a sunflower field, which is a famous area where they grow sunflowers to harvest the seeds. It's always a nice ride. Okay, so there's speed, distance, and time. The yellow box on page 10. By the way, this is going to be a short video today. We're just going to handle speed and move on. Tomorrow will be a little bit longer one with graphing. Okay, so speed. Yellow box, speed equals distance divided by time. You've been doing this forever in math class. Solving for speed, solving for distance, solving for time. Typically it's in miles per hour. Okay, miles for distance, and time is in hours, because that's what we use when we're in America. But in science class, we're going to be using different units. Here's the magic screen. There he is. Uh-oh, magic screen just got turned off. He's coming back on. There he is. All right. So, distance, we're going to use a D for distance. It's going to be in meters. That's the British way to spell meter, but we spell it M-E-T-E-R in America. Lowercase m for meters, but this could also be kilometers. Okay, remember kilometer, 1,000 meters is a kilometer. Time, we're going to use a T for time. Unit's going to be in seconds, but it could be in, with lowercase s, could be in hours, as in kilometers per hour. So your speed, typically I use a V, but I've changed it to an S this year to make it easier for you guys. S for speed, and it's going to be meters per second, okay? Meters per second, or it could be kilometers per hour. We'll get into that in a little bit later. So there's your basic units for speed, and we're going to keep this thing moving along. So, again, this is all review this week. We're going to go going back to previous handouts that you had. Go to this page. You need to see it. This one, okay? Average speed problems, and it's notes. Pause it, find it. Here we go. Okay, solving for speed. You're solving for speed, distance, or time. Okay, the basic way, solving for speed. This is the world speed record on water was set on October 8th, 1978 by Ken Warby of Blowering Dam, Australia. If Ken drove his motorboat a distance of 1,000 meters, there's your distance, 7.045 seconds, there's your time, how fast was his boat going. So this is easy. Write your formula in all problems. S equals D over T. Plug in the numbers. 1,000 meters, there's your distance, and it says distance. Divided by time, 7.045 seconds. Gives you, when you divide it, top divided by bottom, round to the nearest hundredth, gives 141.94 meters per second. You read this top down. Meters, that line means per second. Okay? That's the easy one. Write the formula, plug in the numbers, go. The next one, if I can get it to work, there we go. Solving for distance. This one's requires one step. Hans stands at the rim of the Grand Canyon and yodels down to the bottom. He hears his yodel echoing back. I'm sure it's on the screen. Hans, here's Hans. Here's Hans. It says 12 second. Uncounted floor. 5.2 seconds later. And we're using 5.2 there because the it's an echo. So the echo is down and back, and I took the time in half. And we're using 5.2 seconds, right? 5.2 seconds there and back. We're going to use 2.6 for time because it's down and back. This is a trickier problem. So I'm spelling it out for you. It's 5.2 seconds down and back with an echo. We cut that in half because you just want to know how far it is down to the bottom of the canyon. So you can use half the time of 2.6 seconds. That's where we got that from. That's what it says. Use 2.6. Okay. S equals D over T. Start with your formula. The speed is 340 meters per second right here. Over 1. We can put that over 1 because we're going to cross multiply. D, we don't know what the distance is. We're just going to put a D there right where the D is. Put a line underneath that. We put the time, 2.6 seconds. Cross multiply. D times 1 is D. And then going the other way, 340 times 2.6 is on the other side. What you do on one side of the equation, of the equal sign, you have to do on the other. A balanced equation. And 340 times 2.6 gives you 884 meters. So it's about a half mile down. Okay, so plug in your formula, cross multiply, solve for D. There it is. The third thing to solve for is time. So we solve for speed with the top one, with the boat. We solve for distance with Hans at the Grand Canyon. And next we're going to look at solving for time. This one requires a second step. So, according to the World Flying Disc Federation, on October 8th, make sure that's all on the screen, 2000, Jennifer Griffin of Fredericksburg, Virginia, threw a frisbee at distance. Here's your distance of 138.56 meters to capture the women's record. If the frisbee was thrown horizontally with the speed of, they give you the speed, 13 meters per second. How long did the frisbee remain aloft? So now you're solving for time. Start with your formula. S equals D over T. Plug in what you know. 13 goes under the S for speed, because that's meters per second. Distance we know. A distance of 138.56. Okay? Cross multiply. Put this over 1. You can do that legally. So you have a balanced equation, two fractions, over T. Cross multiply. 138.56 times 1 gives you this over here. 13.13 times T goes on this side, on the right side. But we still don't, we're not done yet. We still have to separate this variable. Okay? So we're going to divide both sides by 13. You can divide this, get rid of this 13 by dividing it by itself. Gives you 1T, which is the same as T. And now 138.56 divided by 13 magically gives you 10.66 seconds is the unit. Okay? Again, divide both sides to separate the variable, and you end up with T. equals 10.66. Little trivia for you, if you have time for some trivia. Frisbee, the word Frisbee came from the Frisbee Baking Company. Back in early 1900s, there was a baking company in Massachusetts, and they were called the Frisbee Baking Company. They had pie pans that the workers used to throw around on their breaks, and they flew pretty well. They were shaped like a Frisbee, but they're metal pie pans. When plastics came into vogue in the 1940s and 50s, somebody remembered the idea or saw the idea of these guys throwing these pans shaped in that Frisbee kind of shape, and molded a flying disc in the shape of one of those pie pans, and to honor the Frisbee Baking Company, they named it the Frisbee. So there's some trivia for you. All right. Find this worksheet. Speed problem worksheet. Pull that one up. I've done a few of these for you. So there's the first one. It says calculate the speed of a car that went a distance. There's your distance of 125 kilometers in 2 hours. So S equals D over T. Now it should be set up. Distance is 125 over 2. Gives you 62.5 kilometers per hour. Read this top down. This is 125 kilometers in 2 hours, so it's kilometers per hour. The next one, there's your distance, there's your time. Okay, set it up just like I did the first one. Distance divided by time. Okay, this one's a little trickier. There's a bird flying. How much time does it take a bird to fly at a speed of 45 kilometers per hour? That's your speed. Travel a distance of 1,800 kilometers. That's a long ways. Okay. So 45 is the speed. That goes under the S. 1,800 goes where the D goes, because that's the distance. Bring down your T. It should be a lowercase t, but I didn't do that. So you're going to cross multiply. 1,800 times over here gives you 18. 45 times t gives you 45t. Now you're ready to divide both sides by 45 to get rid of this. But what you do on one side of the equation, you do on the other, and you get t equals 40 hours. That's a long flight for that bird. And then the next one. This one you're solving for distance. So we solve for speed, we solve for time. Now this one's example of one solving for distance. Comet cruises at 50,000 kilometers per hour. That's pretty fast. Okay, 60,000 miles, or 30,000 miles an hour for 4 hours. Total distance, so S equals D over T. That's the speed. Goes under the S. The distance, we don't know, so bring down the D. The 4 is the time, 4 hours. That goes where the T goes. Cross multiply. D times 1 is D. 50,000 times 4 is what the equation is going to be, and that equals 200,000 kilometers. That thing's traveled in 4 hours. Okay, and the rest are just variations of those. I did 3 of them as examples to see how to do it. That one's for distance, this one's for time, and this one is for speed. Okay, so you can use this as a reference. You can use this as a reference. Okay, how to solve for those. Last thing, speed challenge, guys. This is a real simple one, real fun one. I don't know how some people have the same speed of regular walking and fast walking, but they did. Here's how to set them up. You've got a 5-meter path the whole time. Let's say I was hopping, the Easter Bunny was hopping 5 meters in 2.5 seconds. S equals D over T. Speed equals 5 meters divided by 2.5 seconds gives you 2 meters per second for that one. And then you just do the same thing for the rest. Distance of 5 meters every time divided by whatever this time is gives you some speed in meters per second. All right, so that wasn't too bad. Kind of painless, 15-minute show, we're done. Tomorrow might be a little bit longer with graphing. I might break that up into 2 different lessons. Actually, I might do one on Thursday, one on Friday. Keep them short and sweet because you have some other stuff to do. This is a review again, and you've got a couple of worksheets to do as well. So thank you for viewing, and adios.